All right, let's talk about line graphs. To start though, let's talk about what it means to be dependent and independent. Well, think about it in terms of you depend on your parents. Your parents are more independent. You start with whatever's independent. I want you to write this down. This is what you start with, okay? Time can be independent. It just keeps going. What's dependent then, if it's dependent, it depends on what's independent. So this is what we start with. This depends on this. The dependent responds or is taken care of by the independent. Okay, so if we're making a line graph, this is my x-axis and this is my y-axis. So we're starting with the x, and that determines the y. A company that makes plastic knives is looking at its weekly sales. The graph below shows how the number of knives sold is affected by the price per knife. So the number of knives sold depends on the price per knife. So this is my dependent variable. It depends on the independent. Price per knife is independent. We're starting with the price per knife as my independent. And what depends on that? My y-axis, my number of knives that I sold. All right. A good way to remember this too in science is dry mix. D stands for dependent, which is the y-axis. And then this is my independent, which is my x-axis. Now these other two words are science terms, respondent and manipulative, but we're not going to get into that with math. So dependent is the y-axis, independent is the x-axis. But I want you to understand the concept behind it as well. Okay, Sam works at a water park. He notices that the daily high temperature affects the daily number of tickets sold at the park. So the temperature depends on the number of daily tickets sold depends on what the temperature is. The higher the temperature, the more that's, so we're starting with, this is what's independent. We can't control this. This is controlled by this. Okay, so what's dependent? Well, the daily number of tickets sold depends on the temperature. Okay, let's look at it now without a graph. A graph in an atlas shows how a city's average temperature varies in relation to its distance from the equator, which is the dependent variable. Okay, so what depends on what? We're starting with the daily's average temperature, which depends on the distance from the equator. Okay, the temperature depends on distance from the equator. So the distance from the equator is independent. The temperature is dependent on that. The amount of a certain medication taken in the morning influences the amount of sleep at night. So how much sleep you get at night depends on the medication. So this is the dependent, which makes the medication independent. A function uses the input f to compute the output c. So what are we starting with? We're starting with f, which determines c. c depends on f. F is independent, C, or Celsius, is dependent. Okay, so why are we doing this? Well, we want to figure out which on your graph is going to be your x-axis, which is oftentimes, and what's going to be on my y-axis. Okay. All right, next. So the next skill we need to work on is variables, which we're going to use a lot this week. We're going to be making both equations and expressions. Below is the table of values of a function. Write the output when the input is n. Okay, so to get from here to here to here to here, This is my independent, this is my dependent. This depends on this. So here, I'm gonna either divide by 5 or subtract 4. Here, I'm gonna divide by 3 or subtract 4. It looks like I'm gonna subtract 4 to get from here to here. So to get here, it's n minus 4. All right. Okay. Mary earns $20 for each hour that she works. Number of hours works is my independent. The amount she gets depends on the hours she works. $20 each hour. Use the information, fill in the table, and then we're gonna plot them. So she works 3 hours, she makes 3 times 20, which is 60. 7 hours, 7 times 20, 140, 9 hours, 180. This is setting us up for our line graphs. So now I'm gonna plot 360, and I could rewrite it as an ordered pair if I wanted, but I think we can do it without rewriting it. 7, 140, 9, 180. So this sets us up for our non-concept of, is this linear? Is this a constant? Are we going up at a constant rate? Well, one way I can check that is, can I draw a line straight through these? One straight line. I should be able to. Yeah. If she works 0 hours, we know she'd make $0. Let's see if it goes through that. Yeah, it does. Now this can't go to the negatives. We can only stick in quadrant 1 for this data. Some data will let us go to other quadrants, but you can't like work negative hours, so no money. All right, that is setting us up for creating these line graphs. This function table will as well. Okay, use this function rule. Y equals 22 minus 2x. So y is going to depend on whatever x is. Let's say x is 1. So we can plug 1 in here. 22 minus, not 21, but 2 1s. 2 1s we know is 2. So 22 minus 2, y equals 20 in this instance. Okay, we'll do the same thing with the number 2. 22 minus 2, 2's. 2 2's we know is 4. So 22 minus 4 is 18. Okay, this should be linear. We should notice a pattern as we go. I'm going to just plug in 3 here and do this one in my head. 2 times 3 is 6. 22 minus 6 is 16. Ooh, we don't have 4 here, so I can't just watch this pattern and put in 14. We actually have a 5. So let's plug a 5 in here. 2 5s is 10. 22 minus 10 is 12. Okay. Notice I can't just keep going down. If it had the number 4 here, then yeah, I'd put in 14. You don't have to write that in there. But that is a linear function. Okay, so now we're going to work on graphing lines. Okay, it does not give us any information except for this equation. Okay, so what are we going to put in x and what are we going to put in for y? Well, we're going to have our independent, our x. We can put in any of these numbers, and then the y will depend on that. Here's what I want you to do. I want you to always use these numbers. We're making an x and y chart. Go ahead and do that, a t chart. And we're going to use the number 0, 1, 2, 3. All right, we'll keep it simple, 0, 1, 2, 3. So I'm going to put 0 in here, just like we did on that last one. 3 zeros plus 2. 3 zeros is 0 plus 2, give us 2. Now we're going to do the same thing with 1s. 3 1s plus 2. 3 1s is 3 plus 2, 5. Now I'm going to do the same thing with 2. I'm going to put 2 in for x. 3 2s is 6 plus 2, 8. Now I'm going to do the same thing with 3. And if you want to write all this stuff down, great. It's good to develop the habit first, and then shorten it and do it in your head as you go. 3 3s, or putting 3 in there will give us 11. Okay, so now we have 4 ordered pairs. We have the ordered pair 0 2, 1 5, 2 8, and 3 11. See how we did that? We could have kept going. We could have gone all the way up to 12 if we want. But this should give us enough information. So if I put in 0, 2, so I'm going over 0, up to 1, 5, 2, 8, 3, 11. If I would have kept this up, you know what 4 would have been? 4, 14, which actually would have been off the graph. This should be linear. Because we don't have exponents, I should be able to draw a straight line up through it. We could extend our data on and on and on. Okay. So that is how we graph equations. We make a t-chart, use the numbers 0, 1, 2, 3. I like using 0 so you can see where it crosses the x. And we go from there. Okay, let's do one more of these. Y equals 2x plus 2. Okay, we're going to do the same thing. We're going to plug in some independent variables, the x, and we'll see how the y is determined by that. These are independent. You can use any numbers. I like 0, 1, 2, 3. Okay, so just do this one. No, put that one somewhere. Let's do this next one instead. Sorry, let's go to number 8. This one's a little easier actually. Y equals 2x. Okay, if I put 0 in there, 2 zeros, 2 1s, 2 2s. Sometimes we're going to have negative numbers with this topic. 2 3s is 6. Okay, so now I'll plug these in. Let's go ahead and one more time write the ordered pair. So now I'm going to go to 0, 0, 1, 2, 2, 4, and 3, 6. I could have done a negative in here if I would have wanted to get a little fancy. Let's say if I would have put a -5. 2 -5s is -10. So I could plot -5, -10 down here, and I should be able to draw a straight line that goes right through all of them. All right, that is the beginning to line graphs.